fine. Okay, fine. So good evening, everyone. Let's proceed with our class on NEET UG physics. So hazik akoina tawmisi work energy power tawba hogre mamangda akoina kai tawgre habadu yengasi I'll just share the screen. So si lere duga mamangda akoina kai tawgre mamangi have matamda mamangi sisi wamdo mali aduna sarna mamangi da work energy power gi da work done gi kaidoba definition ji kaino dot product force and displacement. Sometimes akoina sumain tawrji ai small work done or work done as an integration of f dot ds and duga fs cos theta silere dot product ai cos theta ni adi cos theta hape multiply kaino the my vector ji lokthokpa matamda adi magi magnitude of dot product and then work done see changing kinetic energy lay changing kinetic energy kai de lai no sidagi noigi kinematic equation gi third super kinematic equation do adu dei lai ni then aside akoina kai khangi habada som side ta ke do work done lay and work done ga energy ga si amana amagi equivalent oinai auna som the work done lay som the work done or energy like them ni the energy which is associated with velocity initial velocity final velocity initial velocity duna initial kinetic energy ne na thonjala final velocity ga associate over energy ki term duna final kinetic energy in thonjale aduna they are of the same form half into mass into velocity square aduna kinetic energy is half into mass into velocity square sumai la ini na kuin togre aduga koina kedo we have the question gumba hot kre ka so sorry likido kai silere then question kra hot la kai no kra ka sumai to dan last key class kini nei notes pa magadi sir da laigani hands out sir na hand out ka thadokrabani ka thadokrabani di every class check loiba group ta dum thagalakpani ba ka and recorded sessions YouTube ta available oibani ka NSH project ana N stands for nature, S stands for science, H stands for humanity. So nature, science, humanity NSH project and laibani adum yengo aduga ngasigi oinadi class hourzi class housida koina kai yogre notions of work and kinetic energy the work energy theorem si togre kai bo togre ko gida noi khangbra ningjingbra sigi
question number 11 number
okay si bo togra ba
12
okay
12
12 got 12 togra got so see the idea is certain to it's in every question this are to roge kai have the sarna kasu loibangam haidi sargi sarna pami ba target achieve to ngam moiba every question kuding sarna sum hol lai do question kha live simple ba noi ngam do man bi skip to se noi dum try to ko adu noi de lu do man ba kitang hatki oi ba ha question kitang ka twist to man ba natrang kitang new oi ba ko adu mai yam live ma oi do question oi ga adu di start to ge ba ko yam ka hena live di skip to ge so 12 folk to gre hare ko a body moves it blah blah the work then angle put on hare so 13 a body constrained to move in y direction is subjected to a force given by higher magi force ijk magi force ki kedowa resolve to waraga magi ijk gi the resolve to my units in pire so the work done by this force in moving the body to a distance of 10 kedowa jk haitare ko along y axis and have during the city kai tarni have the answer sheet adum direct hai work done ji kaino 15 into 10 150 joules adum tare ko gyan tabra hai se kai no am tam da dot product ni na ngasai gi I som da di kaino yaudre da hai di dot product di kaino have da a1 I cap a2 j cap sorry yes a1 I cap a2 j cap a3 k cap ka b1 I cap b2 j cap b3 k cap ka dot product lo da a1 b1 a2 b2 a3 b3 type so magi distance ki my vector z position vector z I cap ki 0 money and k cap ki 0 money ko aduna 0 duga -2 into 0 6 ka 0 0 and 10 di 15 ga into to ni j cap masen into to ni 150 tare ko so the option is tarni then question number 14 when a body moves with a constant speed along a circle no work is done on it no acceleration is produced in it its velocity remains constant no force acts on it so sigi sikar manchumni no kanano ma hairo sat hairo matam yam sangan da bida
no work is done on it
okay no work is done on it very good
displacement zero displacement to zero oidu ba haidi circular path ta chatpanina
no sunanda lale displacement zero oibai natte displacement di lei ko circular path
90 degree over.
lei kaigino kana haiba ngamni sunanda su dum haibu yes 90 degree oibagi yandabra habidi force ki direction ga displacement ki direction ga f dot s ni dana work done ja aduna force ti towards the center neba centripetal neba aduga work done je tangential neba on tangent ka radius ka always 90 degree oidana on cos aduna dot product lawuda cos 90 di zero ni dana ko adugi oigadeba sunanda gyan tabra
oh sir
I got so do mine okay anyway sometimes misunderstanding them yawn but conceptual clarity got see like so okay so yeah let's move on to the next question. Kinetic energy, so a particle of mass 5m at rest suddenly breaks on its own into three fragments. Two fragments of mass m move each move along mutually perpendicular direction the lay with speed v each car. So mass m each other the remaining 3m so the energy released during the process is and I have a call. So CGC noi gamgadra certa una pabra hiro. Yam live question. Ado sir na yam lai na noi na as kanin sir da to hirak tanawni na yam lai na haizen banate ko noi ta saying still if you feel that you struggle in this question let me know I'll do it. Sir tawse ka okay fine sir tawge ka duga noi na si 2000 sir gi 2020 bodang yawne ka no 2021 2022 2024 fawgi da sigi stroke gi makata ko question gai da no yengo PYQ du da adu yawra gadi tawsi sir da tharo ka adu dum tawsi yani okay yeah tawthar ji let's start kitang chahon ge no yeng da nungai na ka so sida haisi kaino have the a particle of mass 5m at rest suddenly breaks on its own into three fragments. Now, how's it called? Akoi the kai knowledge laire hamatam the conservation of linear momentum the concept laire akoi the ka aduga amana kinetic energy ki formula du khange ba hauzik called. Adu ani du khatang panje take and pan paloji ka auna kaidawni conservation of linear momentum ni matungina haurakpa matam na 5m mass lay and my velocity is 0 never is equal to hiraga ngasagi kedawa two fragments of mass m each move along mutually perpendicular directions in hierarchy ko adu ergadi m hiraga magi kedawa mutually perpendicular direction with speed v each 7 have ko so m v I cap hiraga plus m v z cap hiraga plus 5m nina 2m ama m chakre audi kai lemawre 3m lehawre and then CC de khang de kai no have aduduna v dash harga k capital akadra la oidra the energy released during the processes have a okay fine so adu ergadi masi mazi k capital chat kadra chat loidra have the chat loy ko k capital chat loy so anyway 3m harga sum v dash vector kind of sum isolazi ko kadom du chatinu khangdeba ko aduna sumaina hairs natragana atopa noina ijk da sum thamningagana atopa thamasu yai so let's say some magi so vx I cap plus vy z cap plus vz a cap haira sumaina third but again aina si tawri je amarom da tawram moidabani ko ai hajikta sum haidi keno tawre habidi kaino have the energy released during the process so energy release haragadi kaino have the potsi kaino have the maji hana rest lerame then audai kaidorokani ha matamda after fragmentation haigadra ko after moi kaithar matumda after it broke kaidoni have the they will move it kaidawa velocities ko id with its own velocities aduna adudugi total energy du kai ta gadoino na have ne ko so koina half mb square plus half mb square na sisima layani anijima but magi third ki velocity sidi akoi kaya no khangbra have the khangde ko masi aina sumaino dum tawna fabra maiji ka momentum je ka duna sigi sigi velocity putoksi ka koina si 0 taramnina kai tani ha matamda masagi 3m vx I cap ka Zika 3m vx I cap plus 3m by z cap plus 3m bz k cap is equal to haraga mv I cap plus mv z cap ko yare sumai len aduda sigi posi asomda pubanina aina kedo sige have matamda minus oina hapage sigi sida ko let it be minus. So C is a minus version of C is a minus version of a aduna ina compare to matamda VXC kaiga manarni have the MM cancel sakre ka. So 3VX is equal to V aduna V by 3 layer ba VX layer. Adumain to udana nei kana no at rest. Sir, total momentum velocity is 0 tari se amta to biyo at rest the velocity 0 natra aduna this momentum 0 tiny okay sir no che can I'm really sorry. Yes Kingston rest manina magi moment the velocity 0 nina momentum the mass into velocity ni dana ka adugini so adum kya ta dadi tumharo cheta hang kira madang kira ka then again vy di kai tani chap manana vy su sida minus amwala me ka so minus v by 3 minus b by 3 tarni and then vzt kai tani bzt 0 tarni kai no si yaw de ba auna advain le ni compare to ini ko si sa adu beta argadi hazik hilere ko khoida aduna total keno puthosi ko total momentum puthosi sorry total momentum puthokata nate energy ada total energy is so total energy is kind of the half mv square ka plus half mv square plus haraga ngasai sigi v dash square je half haraga 3m haraga kedowa v dash square haigedam ne ko or natragana kuina kai haisige ha matamda ngasai magi kedowa velocity is kai no ha v by 3 ne ko auna magi velocity is ai is kai no to v dash is equal to kai no minus b by 3 I cap or any and then minus kedoba b by 3 z cap or any ko si sumai len adu ebata argadi akoina kedoni ha matamda v dash sile ko adu di aina zik v dash si half mv square ne ko aduna magi magnitude haitare ko magnitude puthoga or v square hai ge haragadi kai oini ha matamda b square by 9 plus v square by 9 aduragadi 2 v square by 9 aduradi kai tarne have the root 2 by 3 tabra root 2 by 3 v tabra something like that so main tabra into is like a 1 second can to sile dudi v hana puthoki gese v is equal to kai tarne b is equal to v square by 9 plus v square by 9 ko sigi minus a common logthoga adana twice haraga kedowa b by 3 into v by 3 into cos 90 degree di 0 ni dana ko cos 90 degree di 0 ana kaidorni ha matam da cc root 2 by root 2 by 3 hetare ko v tar ne v dash ana v square cc to bataragadi kai lakani ha matam da sir dum kena to ko sangni ge ko v whole square step ama odi kai dorni si ja have the mv square tarni half plus half t 1 ina ko natragana na kena to ge haragana sumain to guna kai fabrium ko sir em to ge mv square si common lower ge odi aham besi da half am lebra second gi da half am lebra third ki da 3 by 2 am lere and then root 2 c square to di 2 by 9 am lere yan tai ko so adudi cd amuka kaitani ha matamda mv square tore half plus half t1 aduga cg 2 ga kakre so 1 by 3 tare ka so 1 plus 1 by 3 tare adudi 4 by 3 mv square na ka so option number d tare ka so gyan tabra si se
Yes, sir.
tai ka Okay, fine. Sir, you kitang sang aba. Sise kitang sang e sumaina kalam da su yabani ka. Biti kaino ay matam da ngasay gi kaino se. Kaya ni. Poche kaino poche rest laibani na ka. Fragment je. Ay sise na yam sang hot kre. Sigi poche kai reba. Part ama som chakre. Part amna som chakre. Part am som chakre. Ka. Adi whatever. Just like sumain to. Si poche suddenly kai ko matam ji da ka. Sumain to sumain chalewa. Si passion matak chakre ba. Yare ka. And then x-axis size now, x-axis y-axis ka. Ado di yung kitang pazaro eh, sige kano da ka. Kamain chalhan sige da amana som do chalhalawa ka, amana som chalhalawa, aduga amana matak chalhalawa, aduga hadi amazina season som paito kreba, amana som paito kreba. Ado obviously season som da paito ra kaneba, cancel out chatna ba ka. Aduga momentum gi conservation of momentum palaga akoina sigi posi resolve to matam da siziga habadi siziga mana kaktana ba si mana kaktana ba adu ain to ga si yam line tar kani bu ko but adu nat ta vida akoina ko kamain khan be ya matam da aziki akoina kenoze kedo ba mass se total mass 5m ni da au da m mana x ki kadi with velocity v x-axis ki positive x-axis set kreba m mana with velocity again v y-axis ki direction the z cap ki direction chakreba remaining 3 mg di magi kedo we have the mazi kai the second have the x ka y ga gi mayai the satlani ba ko aduga magi velocity duna kai oini have matam da koina ngasai gi magi velocity na te magi momentum du kai oini have matam ngasai gi kaidoba x-axis ta leiba momentum duga y-axis ta leiba momentum duga adudugi resultant mayai do aduga exactly opposite oigadam neba sarna haining is kaino habda sida momentum am leire p ama sida zum momentum am leire p ama au sigi momentum je kai oidino hamatam da moini gi resultant sije moini gi resultant si momentum je exactly opposite oigadam neba ko aduna kai oini sir harake munataw si p dash neba ko sigi momentum ji kaino mb neba sigi momentum ji kaino mb neba kenda ko aja adu di sisi di kaino habda m cd kaino Pythagoras theorem na tra Pythagoras theorem ki hypotenuse na tra auna p dash obviously p dash kayo ni have the root over p square plus p square adum masa mathan do oisa do leira bane gyan da braija auna root over p square plus root over p square di kaino have the root 2p oido leira bane the root 2 har kai root 2 har ga p di kai no habda magi ngasai gi momentum do ko this is p dash and p dash muka yemko sideyong yamone ko yam live poni sir na dik to do ji noi si je kitang chingat ke ko chan re de aduna som side di kai we ni have the 3m never my mass ko and my velocity b dash never som the di root 2p natra root 2p di kai no root 2mb neba sidana kai 3mb dash mm ka kraba au di v dash kai tare root 2 by 3b sumain to puto ji ai root 2 by 3b yan tai kai je sumain na vector de result to dasu pau phone brasar na to ija
Oh, sir.
waste ti mayam lai ni bu solve to bagi ko aduna noina sumaina khallaga solve to si ai natraga sumaina taurasi yai noi apambani ko so again sir gi jungai hazik aduga muka noi de takpada aina sumaina han software sumaina adu atopa amada class amada tak matam dei totally new way atopa nong talak paji ai ai kuda ki lakpada ne hana khalako khan do ai panjali ne ko noise with practice adum keno tor kane ko makhan way de dum solve to ya ne anyway so question number 15 ji yare na lawrage ko yarabo noi mem le mak
Yeah, sir.
great. Now let's move on. Question number 16 is okay. A body of mass 4m is lying in XY plane at rest. It suddenly explodes into 3 pieces. The 2 pieces, blah blah. The total kinetic energy generated due to explosion is an error. See the have the yam lie. You know, body of mass 4m is lying in xy plane si je tawzi yam thuna tawzi ka haziki question aduga haidi paikha kai yuma nang na sigi si hanjan hot ki bata ga di siguma question je ai paikha da siguma question am hange ba nang combine to ga kyam thuna solve to ga ge do adudu hasarji hairake ba sigi question sida example lower ga tare ko atopa question or do id sumaina ta examples na jikta khangre ba kai khangi ha matam da sarna ekta hai gibdo si toraga som to wana ko ana sigi p ji kaino two pieces each of mass m na tra ana p mb som du kaino p is equal to mb adu ji sigi p dash di kaino ai p dash ka e ro da adam isal lagi ko m ji 4m na tra m ni chakra the remaining 2m na tra 2mb dash is equal to higher √2 kayo ni √2 harga mb wani adi p square plus p square gidi root overload √2 mb ka kre audi kai tare v dash √2 by 2 b tare yarba adu the total kinetic energy di kai tare ne total kinetic energy or k total haja k t haga no apamba hairo ko so let's say total kinetic energy is equal to harga half mb square di mb square dum lai jare c gi half mb square di half laire m do the kaino 2m laire kaino 2m ne ko and then v square do the kaino have the √2 by 2 whole square laire ne ko so do the c mb square common law di 1 laire and c half ka c ka kre √2 by 2 the kaino have the 2 by 4 laire ni ko so do the kaino have the half ni cd na tra the 3 by 2 tarba 3 by 2 mb square ya brasi sa
Yes, sir.
yai ko so aduni haje aduna noina kai do ya question je hanjan practice to ga di sarna ahamba da khalak wa khando adudi kitang step se kha sangdra ka kuin changdra ano muka sumaina oina khan manong 3 je khangam ni na je sumaina pa level ko so si ji ne practice with practice noina kai pan mana thu ni have the exam that it's all about speed ko divani so yare question number 17 an engine pumps water continuously through a hose. Water leaves the hose with a velocity of v and m is the mass per unit length of water jet. What is the rate at which kinetic energy is imparted to water? So see question din with kitang ta foi do ma lebo ko kay no di mass ki rate kay ka harak mai na una sa dum tawge sidhai si kay no have the an engine pumps water continuously through a hose. Okay, water leaves the hose with a velocity v and m is the m. What is m? M is the mass per unit length of the water jet. So do the m by the l r or capital M by capital L r mass per unit length of the water jet. Small m is and v is the velocity. So what is the rate at which kinetic energy is imparted to water? Have a neighbor cost. So rate have the always d by dt of half mv square put u have a neighbor. I do the half constant. Then have the velocity to again velocity v is a constant never ko aduna kaidoni have matam the v square is dum constant oire on noida kai lere dm by dt lere ko now see the half v square dm by dl haraga dl by dt haraga half v cube m half mb cube tare answer si ngaubra si step se step ama samgra baina step
Wow, sir.
ngaude ko okay rate on scenario is equal to half v square dm by m ne given dl by dt v na tra the half mv cube ko lakshmi kyan tabra lakshmi kumaktre lakshmi yauriba kyan tabra
Oh, dai.
okay fine Kingston Loya Prithviras Zection Thongamba kyan tabra
Tai sir.
Tai sir. Tai sir.
Okay, fine. So let's move on. Next question to see. Next question. Question number 17. Question number 18. Kanana message thare. No marte thare ira. Don yengi ka. Okay. Natte kone yengi. sorry, question number 18. A shell of mass 200 gram is ejected from a gun of mass 4 kg by an explosion that generates this much amount of energy. The initial velocity of the shell is so sigi question jino ngamgadra ngamoidra khallo aduga ngamni ngamoy sir na tawbiyo haira noi dum tawjargera yamdi live question ne aigi skip tawrge da leire noi lui na khalaga sir taw hairo ainero See, yung ko sida tawag duse. A shell of mass, shell ama 200 gram mass like ejected from a gun of mass this by an explosion that generates this much amount of energy. I am never. Adu 200 gram zigi 200 gram hai m1 into v1 aduga kedoba ade amana kedoba from a gun of mass 4 kg never by an explosion that generates 1.05 kilojoules of energy. So the initial velocity of the shell is an haveneba. The initial velocity of the shell do kayo do know have do the half mv square do kaiga manarni hamatamda nasagi sigi mana generator energy siga mana hangadu ineba adain to hot kadeni. So sir hot pana pabra noi ngamgadra saja hainero
Sir, try toge.
try toge baka okay try toge haida mi to budi yaw bra di luni na khanba shall we move on noi kumbada ta da bra kenum tore haidi noi mic ti on tore duga
Sir, yang kana luroidaba male. Yang kana luroidaba male, sir.
yam kanna luroi to male okay thongumbaga surandaga budi kume atai di lakshmi thongum kari prithviras audagi kingshan loya
Sir, next adam torjida.
Yan, sir.
next am torja sure ba noi the
Yani sir.
Okay, fine. Question number 19. A bomb of mass 30 kg address explodes into two pieces. The velocity of this the kinetic energy of the other particle. Sisu conservation of momentum palaga amadi velocity puthoga kinetic energy putho adum yarni na khalle sisu ko. Yado natro.
Oh, yarni sir.
Oh, sir.
Mathang a particle mass m1 is moving with a velocity v1 and another m2. Both of them have the same momentum, but they're different kinetic energies are this and this. If m1 is greater than m2, then this. Sisu am lai ko. Khangbra sigisa.
Oh, sir.
Both of them have the same momentum. Aduna adu origin hero options yenga karamane na kana tawni. Same momentum layer vanina kaidoni have the m1 na kaigumba m2 dai chawar puta ga di b1 na b2 dai obviously chawar mani. Natra aduga energy to the kinetic energy within a half mv square kadineva. So aduna di kaino have the noisy question number 20 sir na tawzira noi ngamgadra. Question jam live mala phajaba yauri manungda. Sir
Ngamuni,
tawzira
sir.
togera.
Sir, ako amtang try toge.
Adudi try to hairo kay tadin option A B C D. Howzi dum noi class yaw na pen paper pai ba natro.
Oh, sir.
Bye, sir.
Hairo adudi
Yes, sir.
question number 20 ji kay tadin hairo. Just a second. Noi kena okay fine. Taba mi arba?
Sir, B da ama.
Sir, B doing.
B tare ko. Okay fine. Ma'am noi tarba B. Okay. So yengo noi keno da noi gi maningi da ki da B sanar be yengo. Aduga if M1 is greater than M2, then E1 by E2 is equal to B taiba. Sure bana.
Sir,
Sure.
momentum manai habanina mass di kenere do velocity the like mana do
ID thazadeda.
ado C is E1 adi hindi mass awe hai
Mas sawe hai
Sir,
Mas
A
leite.
tado male.
A tadong man bra.
Mm.
Fine, yenga zika.
Mass ka energy ka sir inversely proportional oina banina.
Okay. Kaino into collision. M1 by M2 is equal to V2 by B1. Sidi abra? Sipo ba abra?
sir.
Okay, fine. Now yung ko sida dum bilalore. Both of them have same momentum at the day ni ko and the different kinetic energies are E1. Now let's solve E1. E1 okay, so E1 is going to have the half M1 V1 square. E2 is going to half M2 V2 square. Now E1 upon E2 is equal to haraga M1 by M2 haraga M1 by M2 square square. Adudi kay tare have the M2 by M1 tare. Adun tapidi kay have the E1 is less than E2 tare. Option number A tare. Ngaw bra?
Ngaw sir.
Yung ngasagi B tayo ham buto taram draba. Ngaw mission yung kiyam no male. Ado again, sida kaimta this is class test na take up. Kaimta ikai ganu gyan tada step yaw yung sa exam thumalabe yung. Noi sir na sida si sila is kangbra. V2 by V1 idana.
Contd.
Hadi V1 by V2 is same with the M2 by M1 idana. Whole square silay ba. Lakshmi kangadra. Loya kangadra.
Kangani sir.
Oh, Kangani sir.
Okay, fine. Kingston Thongamba,
Kangani sir.
Anganika. Okay, fine. So let's move on to the next question. Question number 21. A bowl of mass 2 kg and another bowl of 4 kg are dropped together from a 60 feet tall building. Another amana 2 kg, amana 4 kg. After a fall of 30 feet each towards Earth, their respective kinetic energies will be in the form of a car. So it's very simple. V is equal to kaino root over 2ZH to kangbra.
Kange sir.
Kangi ka. Aduna adugi V do 2ZH ni but moigi again kaino have the velocity ze acceleration due to gravity ze mass depend of the aduna moi velocity di manani aduna moigi kinetic energy ratio 1:2 taroidra kaino di 2 ni amana 4 ni. So whole loiba asi question je 1:2 tarne ba. Si kangbra sir na haje pau khongna bra.
Oh, sir.
Moi
Contd sir.
khangdiya. Okay. Khangragadi sir torke ka kem kai de khangdi khangdi hagadam ni very good. Adi very good have the khangdi and having me though that's very good. Adi adumaina hagadam ni khangdi dum yam boloina ko khangona ba tawgadam ne ba. Aduga mina khangi haina ai dum aduina domination ge highway kai je into adu phatte ba. That is not the right way to learn ka. Ana we only have the 60 feet of the 60 feet tall building dagi ball 2 kg ama 4 kg ama thadare animak thadare aduga 30 feet tare tangkhai yo matamda moini gi sida lay velocity si lay velocity v1 ga v2 ga da v1 will be equal to v2 chap manani ba kai no ay matamda v square is equal to u square plus twice as neba u do the initial velocity 0 ni yare acceleration due to gravity z ni aduna height to 30 feet ni the v is equal to root over 2 into 10 into 2 into z into 30 feet na trava s to chamana roi dro v1 to v2 so aduna v1 v2 chamana ni ba aduna kedongni have their respective kinetic energies haragadi k1 is to k2 is equal to half m1 v1 square is to half m2 v2 square ka so aduragadi half ka kakre v1 square ga v2 square ga kakre aduna m1 di kaino 2 ni m2 na kaino 4 ni adi 1 is to 2 tadra kaino di v1 should be equal to v2 neva is equal to v is equal to root over 2gh the formula khangadam neva gyan taita te
Cái sir.
like okay fine so Kingston tất kre anyway Kingston tất kre di my net tất kre ba ka yare Kingston my internet kan wai ta mal anyway fine so haji ki gyan taren lor ge yam live question ni question number 22 a stationary particle explodes into two particles of mass m1 and m2 which move in opposite direction with the ratio of the kinetic energies blah 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 cd no edum ngam gadra idai like ko cd ngam gadra
data lole sir.
kai heba jikido
Data lole.
data okay data loile me Kingston gi ko okay no worries Kingston kem kai de ko so carry question number 22 zino ngam gadram ti yo question number 22 23 24 sa si ahum ji yengo karam batau ji haro do ko yo
Sir, 24 je tawse.
ke ba
24 je.
question number 24 ji tau je ba
24 data hours sir.
22 ga 23 ga di yar ba
Yan.
Sir, asidi yani.
yani ko okay sir ji keno ne dang chak cha da bani champuran cha me si dit la man ngi da sai kitang wa ba gi keno to ba keno sa sening ba ko do ge ne sango ko kelo ska to sar man anyway a particle is projected making an angle of 45 degrees with horizontal having kinetic energy k. The kinetic energy at highest point will be okay fine so now magi highest point the laiba noi adum khale ngoba noina projectile motion sir gi video yeng ba taragadi or sir dagi hana projectile motion gi class ko ma yaw gi ba taragadi highest point the si pochi ko sum haim chalani ko si the haim chalani si aduga si the tarakadani sir na kai high gi hai matlab highest point the vertical component of velocity 0 ni only horizontal component dun du khatang le ni sidadi aduga swai di kai no si lai ni siga lai ni gyan dai ga ja kain to na swai de zu kai lai ni have da siga adege do ba sumaina lege duni and hadi magi component the highest point the particular like right and see the kind of the this is v is equal to u cos 45 never u cos 45 degree khatang lai ni ba ko whatever I cap harga j cap ki di plus 0 j cap kai no ni kam lai te j cap ki di ko auna kai dongni ha matamda magi adudi magi velocity je kai no have the original magi si ke do ba magi v is equal to harga cos 45 t 1 by root 2 1 by root 2 hadi let's say v highest rd kaina v dash ka hajalajira is equal to 1 by root 2 v tare ko and I kept tare and magi the kinetic energy at highest point so kinetic energy z k is going to have the half mv square neva k dash na kaina highest point is half m harga v dash square neva adu di half m harga 1 by root 2 v whole square neva adu di 1 by 2 tare adi 1 by 4 tarba mv square adi kai tarni have the 1 by 4 mv square sidi half of half mv square natro mani ko aduaina aina 1 by 4 ntau da bida can I write like this half of half mv square which is equal to half k yare ko the right answer is k by 2 ngawra
Ngaude, sir.
Keno thongamba yarba
Oh, sir, yani, sir.
so it's a very simple question. Now let's move on.
Yarani, sir.
Question number 25, 26, hello, 27, okay. 25, 26, yengo ngamgadri yengo ngamudyo di start oge. Yengo. Question number 25, 26 yung. Yung. Lado. Yaradra, question number 25, 26 kaze. Yaro idaba mi yaubra?
Sir, adum live male, sir.
Okay. Manba katang lai di kamay tawdino di khangaba ka question je pabada. Kamay solve tawdino khangaba.
Sir, 26 A tabo.
For m are moving with equal continuous the ratio of the linear momentize and half mv square half m go for m go a tabra I khang disi what the yaro sir talk tre polaga budi tholakani half mv square ni na m into v square lani half ka kre ka m 4m le m ni na magi v di kai le ni ha da 1 by 4 v square le ni ba auna ratio of the linear momenta gati amana 1 by 4 4 is to 1 option number C ta doiba question number 26 4 is to 1 ta doiba sunanda gyan ta dabra
Amtang check toge, sir.
Okay to loya lakshmi thongamba prithviraj question number 25 26 se yadra yadana yani di harakanu ko
26 to sir
question number 26 to se ba to 4 is to 1 ta sir na sum khanbada aina sum khanbada ka Max kay do ba tabra
Tao yadre kadai da sorry no khangre.
Okay. K1 is equal to K2 half m v1 square is equal to half 4m v2 square. Yare ko. Adu regadi v2 se kay oini ha matamda kado ba half sakre mm sakre ko na v1 square FD by 4 tarne v2 square ko ay yam samjaning ba tayo do sam mangamdre no nungaron so v1 by 2 tar half v1 tar the ratio of the linear moment gadi p1 by p2 is equal to half m iraga b1 by half m to the 4m ni and b to the b1 by 2 never yare ko half sakre adu di kedoba 2 zina mathakta sakre mm sakre ka the 2 by 4 tar male 2 by 4 which is equal to 1 by 2 oh 1 by 2 dum tai ni ko a dum tai sharna so 4 is to 1 tar chumi ko ni holi ja bra chumi sir na ngasai ne Sarna kay mana ai na ko momenta do no mana han bai ta adu ratio of kinetic energy puthok pa dugini ai ying ai na sai khan gi wakhan do m1 b1 m2 b2 adu ai no khalure moina question jina hang jai jina kinetic energy mana ga momenta gi ratio of the momenta putho hai ne ko ai na opposite on salu adu no 1 ai no 4:1 tar ko 1 ne ko ya again ta so noi si gi sir no hol is no gyan ta hora ba loya ya ba loya
Yani, sir.
okay tong ba gyan ta bra
Sir, adum tai, sir.
okay fine atai di
Tai, sir, tai.
Prithviraj tare
Tayo, sir.
Lakshmi ji tare okay fine great let's move on question number 27 28 29 chi na apam khalo apam
Sir, 27.
27 is ka tos
Sir, 27.
okay fine 27 tosi question number 27 is the kinetic energy acquired by mass m in traveling distance d starting from rest under the action of a constant force is directly proportional to very simple question but arthapasana han bai bam changi ko the kinematic equation mana pananing is ko u is equal to 0 hogadaba s is equal to d under the action of a constant force to constant hai ma is equal to some constant whatever or whatever sorry a the constant hai kinetic energy acquired by mass m adu the kinetic energy putwa the v is equal to kaino have the root over kaino 2 a d natra mani ko sir asi mu kai di line no khallem ni b square is equal to u square plus twice as ni ko aduna ai di kam kai di khang ru kam kai di but u to 0 ne ba s to na d ne piram me si le di under the action of a constant force adu di kaino the kinetic energy the kinetic energy kaino half m v square di kaino 2ad natra adu ergadi kai tai ha matamda half mb square ka so half of ka kre a is constant distance to d ne ba ka auna si le adu ergadi mz kinetic energy ne ba ka k is equal to half m b square which is equal to 2 ka kre aduna m a d hare aduna recorded by mass m in traveling distance d starting from rest in the direction of a constant force is so m a is the constant never but d is a constant not a problem mamla is distance d is d the depend to gani aduna is directly proportional to hiraga aina sida a d is constant or bataraga aina directly proportional to m and location bi ko but d is a constant not tabnina directly proportional to m lo uzi yadre ko according to mathematics sai tare ko proportionality concept ni matungina adi ai kainom to butai kaido butai but the constant force like when conservation of momentum pan was yaro ko potse have the conservation of linear momentum pan be de kai no di mazi accelerate to khalai ni na ko aduna kaido ni have the sidagi rest gi kinetic energy force into ma into d mass into force into displacement is traveling starting under the action of a constant force but again constant force na taumatam distance the man travel to is the same direction in not the have the khang de ko aduna adu half mb square ga manahan basi taseng na lan ga do ni have the yam chumni have the laite ba sigi poche ka aduna sigi sida aina kai do yai but m ga m ka kre aduna mm kakibudai pam de mad dum tai si da su mad dum tai ko kinetic energy da. So moi gi kai tage mte yone answer sir gi ne budi c di tai ko ado c di ta bra ta da mte yo habidi option number A is directly proportional to m kai ma distance in a constant in lower gadi distance depend on when constant lower the other. Nui yengi bro kai no kan ko makti ja. Question number 27 di kai
Sir,
tage
yengi.
kai tai ba
Sir, yengi haiba.
oh yengi ba ko yeng adu haro yeng adu haro
B tayo sir.
B tai ba ko okay fine adu ragadi kai this way don't worry ko yeng si ko phajana it's directly proportional to have a ko the kinetic energy acquired by a mass m okay in traveling distance d starting from rest under the action of constant force aduna for example under the action of constant force habisi mathaktagi mass mama my weight to constant ni ko mg na putharakadoi chingtharakadoi ni mg na awna magi kinetic energy puthoke aragadi jamane half mv square neba na half m v du di kaina da root over 2z h neba ko awna half ga m c whole square la neba aduna 2zh laani 2 kakre aduna mzh layeba ko asagi potential energy to kinetic energy on by wari ne because the differentiation cannot be wari ne ko but sigi pot c don't have the is it dependent on m have the mzh ko m the over ko now kinetic energy do is directly proportional to directly proportional to okay yeah ganta tigize sisi kinetic energy si tare ne ko moina pami si kaina hongbra moi akoi ne sidai sidai yang to sida constant force na hybra constant force na hai ko aduna kaida wi ha matam constant force na koina ma je koina sisi kaino have the f into d ha ne ba so adu kai we have the kinetic energy is directly proportional to d ne ba and kinetic energy is kaino it is directly proportional to kai hai ni mass yaubro sida yaude na so directly proportional to m to the power 0 harakadeba gyan tabra
Oh, tai sir.
tai ko kai no mo force to constant hai gi ni ko si question je adun si um je question phajaba ko section lo dun twist jaw m yaw je koina a ga m ga je punjal la constant force hai ne ko ai ne ngasai constant force and constant acceleration sum ai han han bai constant force idi ram ne den force constant or mass constant acceleration constant or mane ha a de sum ai mind sakki bai ta question am ko han na par kan di constant force hai bani na m a do force ni na do constant or ga d directly proportional to d ni and it is not dependent on m it is independent of m m the can depend on independent or the m to the power 0 hai be ai kai no the m to the power 0 the 1 in ko so ma'am lang kyan ta obra si kisa
Tayo, sir.
Hoy sir.
Tayo
okay
sir.
tai ko thongam ba tar ba thongam ba prithviraj
Oh, sir.
Tai sir.
okay great now let's move on question phajai si question tiktok salo no the hour ko kitang twist si constant force ni si constant force amaru si lines Anyway, question number 28, 29, khal lo, no apam, 28, 29, 30, no apam khal.
$29 oina tawse, sir.
Question number 29 is a particle of mass m is moving in a horizontal circle of radius r with uniform speed. When it moves from one point to a diametrically opposite point, it's higher. Okay, fine. Yam pazava question ni yamna yam live question ni. And okay, they only have a particle of mass m. Suppose let's say Shidagi, the labor mass m is moving in a horizontal circle of radius r with velocity v, mv lereka. She lay diametrically opposite side ta she or kumatamda is the radius ka. Magi kedova mv lerni som the salani and som the salani. Auna magi momentum zikaina p is equal to mb I cap. Sina kaina p is equal to mb minus I cap. Lereka. Its kinetic energy changed by this. Its momentum does not change. Its momentum changed by 2 mb. Its kinetic energy changed by this, and I will call. Its momentum changed by 2 mb. Let's say this is P2. Let's say this is P1. P2 minus P1 is equal to minus mb I cap minus mb I cap. Minus 2 mb I cap. Yarba. The magi magnitude kaino P2 minus P1 magnitude kaino 2 mb tare lore. Abdi kaina sir namka si sumain kadang to ning deba ko. Sir namka atay option me amdi kaidobagi kaidobagi chumino or sorry kaidobai lali na yengjeba. Kinetic energy change by mazi constant velocity v the chat in half mb square dum oil in kinetic energy do not change to the kinetic energy change to the kinetic energy is not a vector, so it does not change. Momentum does not change. Momentum is at every point change. Momentum is a vector, and see some point or see some point. Momentum gi magnitude change to the way I did tauroid, but magi I did constant uniform speed v na mb do change it tauroid momentum. But momentum gi magnitude have momentum have never, and momentum is a vector quantity, so it does change. It does not change. It's lali ko. So system lale. Momentum change is to make kinetic energy change by kinetic energy change to the kinetic energy do not change. Option C is the right answer. Gyan tarba?
Oh, sir.
Okay. Adudi next question yung aziko. Arrive question in the city. So question number 28 yaren lorge. So work done by a variable force. I sibo takravani taktiba. Yes, she's in the first kiddo. F work done is equal to integration of f dot dx hygera ds hygera or w equal to f dot s hygera whatever call. So area under force and displacement curve adu da lo yare. So higher question number 30, 31, 32 no epam omkalo 30, 31, 32 is the call. Natraga sir asi loinamak laire haragadi amka makang to thadeba. Higher 30, 31, 32.
Sir, sidi loimak laiba male.
Loimak laire baka. Okay. Ma'am, adudi no kemta kenu tawning balay traba kem haning balay traba ataydi
32 जी सर
32 is okay. A body of mass 3 kg is under a constant force which causes a displacement s in meters in it, given by the relation this, where it is in work done by the force in 2 seconds is, and I have a okay, fine, let's do this. Let's do it. Let's do this. Okay. 2006 question. Now, a body of mass 3 kg is under a constant force which causes displacement s in meters. S in meters in it, given by the relation S is equal to 1 by 3 t square. Velocity is equal to ds by dt is equal to kaitani 2 by 3 t. Acceleration is equal to dv by dt is equal to 2 by 3. Work done by the force in 2 seconds. Work done is equal to m a s. Force into displacement hai tare ka. So m a di kaino m di 3, a di kaino 2 by 3, s di kaino s di s never ka. Now SCS lo yaroi SC kaino have a da when t is equal to 1 work done when t is equal to 2 s is equal to kaino 1 by 3 into 2 square which is equal to 4 by 3 meters. Now 4 by 3 tarni 3 ka craft 4 to 8 so 8 by 3 joules tarni work done. Gyan tadra
Oi, sir.
Oh, yani, sir.
loya yare ko.
Oi, sir.
So yare adudi hairo atopa question number 33 34 kamba tawzige natra adum yarwa 33 to 34 so 30 makhai yeng azira yo si hapet pare yo adu noina ngamoi daba mala de haro
Sir, aigidi yarani.
Lakshmi haro Lakshmi ta dabra
Yarani, sir.
yani okay ada kanu haro thongumba haro Prithviras
Sir, yarani aigi.
Yani, sir.
okay Prithviras thongumba loya zu yare ko.
Yeah, sir.
Next, let's do next question. Question number 33. If a position dependent force F equals on a small volume to gain this the work done. Yang 35, 36, yang 37. Yang ado hai na ro.
35 sidi yarani, sir.
Okay. 36, 37 hai na ro. Question number 35 si yadaba mi yaudi tum hai ro ko.
Sir, 36 se hot se.
36 ho cheba. 35 ti mi amno yar ba.
Sir, si integration tawdun natra.
Mani to gudui ne do. Ngam ni na khan bra. Kumak tren kumak zu tadre.
Yani, bis matang taros.
Lakshmi yare ko. Lakshmi ji ngasai di mic si on di toro makon so ta daba.
Yo, yarani, sir.
Okay. The potential energy of a particle in a force field is this for stable equilibrium. Now, sir, no the potential energy tak 3 in a equation is hot pada yadi yagiroi ka. But equation in tamum gadra han tak to han tak to ge ka. No for han tak to okay. All right. Now today ka let's discuss the idea of potential energy ka. Munataro. It's very important. Potential energy is kaino ta age ka. Yes, potential energy hariba energy si karam kanda tholakani har matamda conservative force amagi action na equilibrium adusu stable dagi ko equilibrium makal ani lai stable equilibrium haiba ma unstable equilibrium haiba ma ko aduna munataw it's very important. What I'm discussing is potential energy. Potential energy kaino and combined to sa haige munataw. Potential energy haibasi conservative force amana kaidoba object ama or any body ama zi magi equilibrium adusu equilibrium da makalani lay stable hai ba ma unstable hai stable equilibrium da gi kay any object ama displace to thokpa matam da kanana habadi akoina kedo hai displace to thokpa matam da conservative force ama adusu restoring oiba nature da ko or restoring force which is conservative in nature aduduna act torama equilibrium da pushana ba honarakani ba ko adu matamda kaidokani have the idea of potential energy comes into play haibadi kaino have the for example pendulum ma sumainjum high lere pendulum ma ko pendulum ma sumainjum high lere black machu jino puram maroi ko kat atopa kitang color atopam sign to ja so pendulum ma sumainjum high lere aina sibo putwe thadare si kaino si stable equilibrium ne magi ko ana aina stable equilibrium da sumaina displaced to matamda restoring force ama which is conservative in nature aduduna masi equilibrium purakna bhona ne on si potential energy yaw ko we yan dai kai ja adoin tawduna aina let's say kedo we have the c pot c magi hazizik si je kana stable equilibrium ne na low by yai pot c in stable equilibrium dagi aina masi displaced to matamda restoring force ama na masi stable equilibrium da amuk puthana bhona rakani ba adugi restoring force to conservative in nature oiniba aduna aduda hadi pochi equilibrium de displace autogadi kedorakani have the potential energy ama yarakani pot to pa so adumain tawdana aina spring amazi just a second spring amazi magi kedo we have the sigi chang sida layame magi kedoba relax state se sibau ne khalajeba on spring je ina stretch to eba stretch to ko matam da kedoni ha matam da CZ magi relaxed position is stable equilibrium ne bako stretch to thwe audi ke dorokani restoring force amana magi towards the equilibrium position chingjana bona ne ba restoring force lay bagi ne potential energy lay ga doise restoring force lay tragadi potential energy lay roi bako na potential energy hai ji kai no hai da restoring force na equilibrium da pusan bagi tendency lay ra ba body amada mazi equilibrium de displace to thokren equilibrium pusalakna ba honaraba then adi potential energy ma develop torkani ba ko so that's the idea of potential energy auna kedoni ha matam da potential energy aji kedoni ka magi okay fine let's say ke hezige potential energy makal lai ko gravitational potential energy lai electrostatic potential energy lai natrana spring force ki potential energy lai high force में हमसे लोइना में conservative force ngata ne ba ko adugini now sir na ngasai dei high conservative force hai si di kai no na hai matam da again path depend to da magi work done je force ina work to matam path depend to da only initial and final position da khatang depend to force bu conservative again sir na hai je kem gyan tar mo kari ma thong ram khang dre na ko sir yam line har ke potential energy ji kai no and conservative force kai no na ko yam lai har ke mun ne yong sida ai example amadi low da biaroi gravitational potential energy oigera electrostatic oigera spring gi oigera pendulum gi anything amadi low da bia spring gi low ge ka so spring am le so sumaina my mass am le this is my relaxed state now now in a sigi spring si aina ke do we have the sigi spring si hezek ke no to tho ge stretch to tho ge mass yauna stretch pudi to gre ko mai ja aina mass di stretch to ning de au nai mass stretch to ro ge okay fine so asumai stretch to matam da kedoni ha matam da sigi line ji kaino this is the kedoba equilibrium position ne ba ko anaina ji kedo we have the magi sigi line ji da gi aina kedo we have the stretch to thwa sigi chang je ana kedo rakani restoring force amna mongon act tor kani ba ko ana restoring force amna sigi masida so sumaina chingjan ja sumain toraga restoring force amna maji asomda chingjan na bohona ne restoring force na ka aduna kaidoni magi displacement di kaino equilibrium dagi asomda equilibrium de asomda chathoki bane my displacement je ko or let's say ds zira or whatever ko ds asomda sum chakidoini ada restoring force am ek tor kane aduna sida aina kaido we have the work khara torani now work done ji kaino work done ji f dot ds ni so f dot ds kaino f ne ds ne cos 180 degree which is equal to negative of fs and work done ji kai tare minus f minus f ds tare this is dw hai tamne ka natraga sumai hai ka integration of f ds cc hai ji adu erga di kai hai ni ha matam da cos 180 degree di minus 1 ni ka so minus of f ds arage aduga fs negative fs tare ka now this is the work done agna work done z minus fs star manina koina kaino ha matam da koina muka potential energy is change increase or whatever change in potential energy is equal to it is most of the time it is denoted by delta u which is equal to u2 minus u1 has u uf minus ui has u change in potential energy is negative of work done wave ko aduna delta uc already masai negative am lejaramnina f dot s or f into s and has ui because cg kaino cg kedoba example cg oina haitare ko so aduna in the notion potential energy ki notion si kaino ha matam the restoring force ama leigadabani equilibrium ama leigadabani equilibrium dagi body ama or object ama ji aina kedoba displaced to matam the restoring force amna maji equilibrium pusalakna bkhona bdo pusalaktri gai di mona potential energy yawnge ba can ta right aduga pusala matung di potential energy zero ne ba now hazik aduna key terms khara haige sir ko haining is ngasai de ke do sir again potential energy is always mangon the changba terms khara sir haige ko duga manio potential energy the changba terms khara lay du kai no have a w na sizina ge ta launa ko quite first the conservative force second the equilibrium is the stable or unstable or be a day aduga mathangna kaino restoring force and then when amaga zukangadam always it is negative of work done adudi amuga change tani ko change in potential energy is always negative of work done na sigi se padana clear oina khangadam ne ko si clear oidraga di yaroi ko adugi ni aduna kaido we have the hazik sir na sigi se matang amam haidara ke ko conservative force hana haige munatau what is conservative force conservative force si kaino hai matam da ko noina suppose let's say the ground the body am lay si body zina na kaido we have the si jaga si da pure si jaga si da pu matam na nang tawgada work done je kaino have the force di kaino force is always vertically downward never mg never and then nang displacement di kaino nang again displacement is sumaina phaina chatle nang sumaina pugera part se ko this is part 1 or sumaina pugera this is part 2 or sumainto purakera this is part 3 ko part 1 de pugera part 2 de pugera part 3 de pugera kaidoni have the magi work done in all the three cases will be the same it will be kaidoba loin chap manani ko work done sir kaidobai manaduinu hai matam da work done je kaino have the f s cos theta ne now f to the kaino f to the weight in always vertically downward adum oile ani my weight to the mg always vertically downward adum oile ani adu nang si som pu nang result to matam da ko si let's say sumaina pu matam ji da result to the som ga chale ꯑꯗꯨꯗꯤ ꯅꯪꯅ CG ꯌꯧꯅ ꯍꯣꯠꯅꯕꯗ C mass ꯁꯤꯗ ꯌꯧꯅ ꯍꯣꯠꯅꯕꯗ ꯅꯪꯅ ꯉꯁꯥꯏꯒꯤ ꯀꯩꯗꯧꯕ ꯁꯣꯝꯒ resolve ꯇꯧꯔꯦꯕꯀꯣ ꯑꯗꯨ ꯅꯪꯒꯤ force ꯗꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯕꯗ always vertically downward ꯅꯤꯗꯅꯀꯣ mg ꯏꯁ force ꯇꯣ ꯑꯗꯨꯅ ꯀꯩꯗꯧꯅꯤ ꯍꯥꯏꯕ ꯃꯇꯝꯗ CGCD ꯑꯁꯣꯝ ꯆꯠꯄꯩ this is displacement ꯅꯦꯕꯀꯣ let's say this is SY and this is SX SX CD perpendicular ꯑꯣꯏꯅꯕꯅꯤꯅ work doneꯗꯗꯤ theta 90 ꯑꯣꯏ ꯌꯥꯗꯦꯕ 0 ꯅꯦꯕ some side ꯆꯤꯡꯊꯣꯛꯄ ꯍꯥꯏꯗꯤ horizontal direction ꯗ motion ꯇꯧꯕꯁꯦ displace ꯇꯧꯕꯁꯦ work done 0 ꯅꯦꯕ always ꯀꯩꯒꯤꯅꯣꯗꯤ horizontal direction ꯒ vertical ꯒꯤ force ꯒꯤ direction ꯗꯤ vertically downward ꯅꯤꯗꯅ ꯑꯗꯨꯅ force ꯒꯤ direction ꯒ displacement ꯒꯤ direction ꯒꯁꯤ perpendicular ꯑꯣꯏꯔꯒꯗꯤ cos 90 degree ꯗꯤ 0 ꯅꯤꯅ work done ꯀꯩꯝ ꯂꯩꯇꯦꯕ ꯑꯗꯨꯅ only ꯀꯩꯗꯧꯅꯤ ꯍꯥꯏꯕꯗ ꯅꯪꯅ ꯄꯣꯠꯁꯤ ꯁꯨꯃꯥꯏꯅ ꯄꯨꯈꯠꯂꯒꯁꯨ ꯁꯨꯃꯥꯏꯅ ꯄꯨꯔꯁꯨ what matters is kayam wangna pukhatke du khatang neba auna kaidawni habada adunadi kaidawni habada magi work done se initial and final da khatang depend taweba nang sumai pugera sumai pura chatkera kaidawni habada sida muka sisi negative work tawudu putharagadi positive work tawani aduna potential energy handarani negative work tawagana potential energy hengaleva if you want increase in potential energy you have to do negative work. If you want decrease in potential energy, you have to do positive work. Amana may opposite oineba. So sumain to conservative force have the kaino habada. The force whose work done is kedoba. Yeah, sorry. I'm really sorry. I'm sorry. Just 1 second. Yes, yarba, yareko. So kitang go wali. Okay, fine. Yeah. So what is potential energy? What is conservative force? Have the ko. Matam yam sangra ba igise. Matam yam sangan gre. Matam yam sangan be ade. Concept am explain to buda ko. Kena to riba. Mayam yari ba. Tari ba. Okay. So this is kind of
Tari, sir.
Okay. Thank you. So part ke doba part depend to the ko. Part independent force and have ko. Part independent force karino part independent or the work done by the conservative force is part independent. On a part independent force high kaino di work done does not depend on part harshi ko do an harshi na masi kaido ni hamatam da CCA can to be work done is independent of part and depends only on the initial and final points. ID initial position and final positions are point have the positions are most of the time conservative force kidi my field and conservative force field and high and a gravitational field electric field ka electrostatic field ka or magnetic field ka moi loinamak conservative force ngatane field labor force kudima conservative ngatane do conservative force kudima field labor haragadi not necessary spring gi field laite ko spring force is also conservative in nature kaino ni nang na spring zi kedawniya matamda nang CG sida pura is nang atan stress tor sida pura azu or sida direct stress tor or smai ngam tor sida pura azu adu tawba ngasai potential energy sigi position sigi oiba potential energy store to the constant oini bu ko sida bu dum to puthorage potential energy kedawa delta u ko f dot s and hybrid okay no cc f dot s and adum high ko fs mak yai half kc high yai adum magi direct potential energy stored ko at x haitare ko cc puto ke haragadi u is equal to haraga integration of negative of work done in a minus dw harani so minus haraga dw d kaino have the f dot ds harani or f dot dx harage dx f dot dx हायगे को है कितंग खक है मागी dx सी असोम द मूव तो थोप द को अना कदोनी हैव द माइनस अगेन स्प्रिंग फोर्स सी कइनो अगेन नो सी सरना बुदी हजिदम हाइपे चौकम हाइगे उन्हें येंगो spring force F से directly proportional to negative of displacement है नो इसी हाना खंगब्रा खंगदब्रा spring force से कदो spring force है the restoring force निको इधर सिल तो इजे restoring force of the spring से सीजी कइनो है बता नंगी displacement की magnitude का directly proportional होई नेबा हाइबदी कइनो है नंग सिगी से याम चिंग थोई के restoring force चावरक कनेबा but force to the swom the चिंग थोपर restoring sorry displacement swom the positive x axis तो होइबा and then restoring force na negative x axis to hoiba adi amana mai direction yawa vector ni na negative ti oina ni ba but magnitude wise ti directly proportional ne ba auna f is directly proportional to x ai ne ba adi proportionality constant do k x and bi kai if you want only the magnitude you don't have to put negative sign if you want to put vector then you have to put negative sign sir na hari si pau phona bra gyan tabra ma'am
Sorry, sir.
Yes, sir.
si yam phajana
Sorry,
clear
sir.
ko suaina adu nang f katang lor ga di kx tang har ri ai ba ko or si su dum chume so du na kai do f ki mo ta nang na kai do ni am tam da kx loro adu ga again dot product ni na masagi another negative from loro ni ko sorry so kai do ni have the adu madam dot product ni okay yaar si dum minus kx araga minus kx force ki no isi again tagadam minus minus plus sa crane ang kalo ya dot product minus sam thole adu duga plus sa crane kalo an integration of f ki di kx ni duga dx layer ni adu di kai do 0 to x forward to ren kalo adu araga di kai ta ne have the k harga x square by 2 har ni ko so potential energy stored si kai no have the kx square by 2 on spring gi ko so si jim khangjalo half kx square har ji ai ko si jim khangjalo spring tying is dai si taction hore makada kedoba again conservative force ai my field legally ko again friction gi nang na si ground ji nang na si box ji jar launching matam da sida potential energy la oiba kinetic energy di change laini or whatever but sida potential energy kam laite kaino frictional force is conservative force not teba ko it if nang na friction force conservative force not sida kaino ha matam da nang na friction na tabu work done ji puthokpa matam da ko kai tani ha matam da let's say friction na tawo work done si ko kai tani ha matam da let's say sidagi na nang si fo work sida tawo da sidai na si fo chappa da tawo da work labor work done du nang sumain to or chalaga or whatever sumain ga to me am chalaga di work done am ta mana roi ba an I did nangi displacement or nangi sorry distance shawri ge work done helakane bu ko yan tai ko ja auna friction gi di friction is not a conservative force and conservative force natamnina conservative force natragadi keno lay via deva restoring force lay roi potential energy should lay roi ko again another case another terms in keno nga say equilibrium equilibrium hai bisi makalani lay equilibrium ji da makalani lay ko stable hai ba ma unstable hai ba now equilibrium has the kind of balanced over no chemistry the zunga equilibrium yoraga the rate of reaction do either side ta dum yam slow ina keno tor chali dana ko abdi equilibrium da dum lining maneva cham chatti dum har ji ai auna kaidoni am the stable and unstable equilibrium lay auna noina kaido we have the noina dipole electric dipole gi da taw matam da su stable unstable adu da fine lay bido auna for example let's say or magnetic dipole electric dipole adu da sumyam lay natra isam samna chai am lay en khala se ko suppose let's say we have a rod here and then mazi hin some of the mazi sumaina hapa thamme now mazi uniform mass ne the cz kaino have the cz stable okay stable no rod tire is yam live example am hai so ana spare am lay spare ji manung da spare macha am lay kyan dai guys spare macha am lay then cz same spare macha ji sarna either we have matamda masi sarna matak dong thamme perfect koina now kaidoni have nang na sigi spare macha je change to position je nang change to nang na swai de thamwa kaidorakani equilibrium da dum halakani ba nang na sigi spare macha swai de thamba kaidorakani equilibrium da dum halakani ba haibidi kaino haibida hasigi sigi bottom je sigi bottom position je sigi kaino stable equilibrium ne and sigi equilibrium the equilibrium ne but sigi kaino unstable equilibrium ne auna unstable equilibrium da di kaidoni have matam da poch amuk hanna haningakte unstable equilibrium da unstable equilibrium da nang tak displace tawraba stable equilibrium da chana bona ne ba but stable gi equilibrium gi di kaina nang tak displace tawraba adum stable da halakna ba hona ne ba habiti stable equilibrium da gi por ama displace tawraga di potential energy develop tawrakani restoring force na maram oiraga unstable equilibrium da gi nang any body ama displace tawraga di restoring force laite potential energy develop taude gyan tabra tadabra hero ma'am tabro tadabro
Tayo, sir.
aduna
Tayo, sir.
aduna
Tayo, sir.
aduna okay aduna energy wise graph ta energy ki graph ta kaidoni ya matamda sumai lerega sumai ler kale si kaino this is stable equilibrium ne gyan tabra ja this is stable equilibrium and this is kind of unstable equilibrium. This is very important. See, no like the thing, Roy. The see knowledge the best of question. They don't hang the dinner take out them hangi. Section na hang the bani. So, adu one energy is minimum energy stable equilibrium. The minimum energy line, maximum energy na unstable equilibrium the line. And adu ada marak saraki meam line. Adu I don't know in a dipole no mama madus tam manevo come. ID kedova. Stable and unstable equilibrium se sile restoring force kaino khange negative of Workdone khange so potential energy no if adum phajana khange na lobu yare ka potential energy as a negative of Workdone ni maji restoring force ama da ka lei equilibrium dagi adu stable equilibrium dagi displace to kan da khatang create tawi haibena chingba all this semya is very important no potential energy ha mgs ha kano ba adu yamna kaine adu the application namne ba ko mgs kaido just magi kaji mg against the sign term mata kakala kanta work done do it restore as potential energy just example ama kalne ba di ko aduga aduduna general of potential energy of the ro anyway oh no say question though sorry yes so the potential energy of a particle in a force field is direct this where n be a positive constants and r is the distance of the particle from the center of the field. For stable equilibrium the distance of the particle is here. So stable equilibrium the ngasagi energy ki slope to kayoini have the zero any unstable the zero a stable the zero a kai have the minimum maximum the slope si kedoni have the magi derivative zero any na slope to zero ni na slope zero as in pau khongna bro gyan ta bro kanam kumak si stable equilibrium ne ba equilibrium the ko
Hoy, sir.
magi derivative zero ta ne ba gyan ta bra ja aduna kai chakra aduna kedoni have the CGC for stable equilibrium so you may write for stable equilibrium pung kya ta again pung kya ta again 9:30 ke lo 9:30 chala mein okay question number 3 ka du by dr should be equal to 0 so nai CC derivative lo kai ta ni minus 2 a r cube minus minus 2 plus 1 lani ka yes plus a by r square should be equal to 0 it implies a cancel to gre ka aduna minus 2 gonna take 2 by r irony adi ila ka is the r square so a cancel to gre aduna 2 by r cube asompu gro 1 by r square sakre aduna si r memory adi kedo r is equal to 2 tar kaidoba b di guys oh aina kaino a cancel sakre ka hala si b ji waina a ne to sale men to panida tarwa answer du dia twice a by r is equal to b tarwa as the a is equal to twice a by b. Option number B. Nengaw bro sir gi jam thumal lab si ja swai ja step am hapura.
Yarni sir khangani.
R equal to A by B. Yare ko. Ma'am. Yauri ba yang ang gi ba. Okay.
Yari.
Yeah,
Yauri.
sir.
Okay, fine. Atai di kumakte.
यानी सर
Sir, yawi.
That's right. Yeah. So okay, great. Gyan butaw bro.
Tay.
आए सर
Okay, fine. So fare pung ji keno tale me pung ji 9:40 tale me 9:30 pau dong tau jam ni 8 taina 9:30 pau 1.5 hours ki ka. So aduna ngasi gi di sida budi lotioning e. So question matang yeng zira the potential nervous system increase. Yes, question number 37 ja torga loshalaji 38 kai ka 1995 ki ja noi try to ro ko ngamdraga sir dairo sir toge. So question number 37 ji what the no idum yeng ara the potential energy of a system increases if work is done upon the system by non-conservative force. Sir na do non-conservative force na potential energy create to swangam deva ana non-conservative ki wajim swai le option A ga C ga jima upai swai leitre ko B ga D ga sida kai odina ha
D
Huh?
word.
Now C is kitang confusing mo bra by the system against a conservative force and upon the system by a conservative force. It is always against a conservative force ni ka conservative force ki against aina kaidoba work to kind. So option B is the right answer ka. So anyway nasi ki disida lo shila zika everyone yarba
यार सर
Yeah, sir.
okay fine okay then thank you for the class ka okay tham nerji ka mang parji good night everyone
Mong first. Good night.
good night okay good night